Hi everyone, this is Miss Graham, and today we are going to be going over lesson 5-2 trapezoids. So go ahead and pull out pages 209 to 212. So yesterday we focused on the lesson that looked at kites as well as the triangle mid-segment theorem, and today we're going to have the following learning targets. We're going to look at developing properties of trapezoids, and we're going to prove the properties of trapezoids. So this is the quadrilateral that we're focusing on today. Below, we can see it says a trapezoid, again, is a quadrilateral with exactly one pair of parallel sides. So when we looked at kites before, we saw that there were no parallel sides. There were two consecutive pairs of congruent sides. So here, the parallel sides of a trapezoid, they are going to be called the bases. And the non-parallel sides are going to be called the legs. So the pair of consecutive angles that include each of the bases are called base angles. So what we're going to do is we're going to sketch a trapezoid, and we're going to go ahead and label the vertices with points T, R, A, P. Textbook's trying to be funny to go off of creating a trapezoid and having four of the vertices, or all the vertices, starting with the four letters trap. So kind of funny to think about that, but after that, we're going to identify the bases, legs, and both pairs of base angles. So let's start with sketching. Let's start with the two parallel sides. So I'm going to put them as horizontal. And I know with the trapezoid, one is going to be longer than the other. Now, I'm going to go ahead and connect on the left side the bases, and on the right side, I'm also going to connect them. So that's going to be an example of our trapezoid. So it doesn't matter the order in which you label each of the vertices on this trapezoid. I'm just going to start in the upper left-hand corner and work like a clock. So we're going to start T, R, A, P, just like that. Now, it wants us to label the bases. So off to the side, I'm going to go ahead and put bases, and we are going to label them accordingly. So the bases that we're going to have, and I'll use some colors, are going to be TR, and we're also going to have PA. Now I'm going to go ahead and label those as the bases on the right side. So we have TR, make sure you put the line segment symbol above it, and we also have PA. Order does not matter here because remember, we're not showing that they're congruent. So next, we're going to go ahead and look at legs. So remember, the legs are the non-parallel sides. So looking at this, let's go ahead and highlight. I'm going to highlight in green. We're going to have TP, and we're going to have RA. Those are going to be our legs. So let's go ahead and write down TP and RA. Next, we are going to have our base angles. So I'm going to write base angles. And that definition is a consecutive pair of angles. So we know for us, looking at our bases, right, TR and PA, what we're going to see is that we have T and R. They're consecutive. Remember, consecutive means next to each other. We saw that in our last lesson. And then the other pair is going to be PA because they're also consecutive next to each other, and they are focusing on our bases. So I'm going to go ahead and label those pairs. So we have angle T and angle R. That's one of our pairs. And we're going to have angle P and angle A as our other pair of base angles. Now keep in mind, even though I drew this picture where, we have our bases as horizontal, they don't always need to be. This picture could be drawn vertically, or we could have it on a diagonal. So just keep that in mind. Now we're going to go ahead and start looking at our next section. Now, previously, yesterday, we looked at the mid-segment of a triangle. So we kind of saw a triangle within a triangle, and we saw that relationship. Today, we're going to be looking at the mid-segment of a trapezoid, but in our textbook, instead of using the word median like they have, we're going to replace wherever we see the word median, we're going to replace that with mid-segment so we can relate the idea of how we found the mid-segment of our triangle yesterday, we're going to relate that to the mid-segment of a trapezoid. Maybe there will be similar relationships, maybe there will be different. So what we can do is we can go ahead and start reading through what we're looking at with the mid-segment of a trapezoid. This is going to be a segment with endpoints at the midpoints of each leg of the trapezoid. So just like yesterday, right? We saw a line. And yesterday, I think we also called it MN. We know that points M and N are going to be in the middle of where they're at, in the middle of those segments. So we know FM is going to be congruent to EM. And we also know GN is going to be congruent to HN. So I'm going to go ahead and label my picture to kind of visualize that. So the next part that we look at, it really goes through what the trapezoid, let's try highlighter, what the trapezoid median theorem is. That is going to be the median of a trapezoid being parallel to the basis. So we already know that these two are parallel to each other. We're also going to say that our mid-segment is parallel to it. So I'm going to go ahead and label those parallel arrows / triangles. It also says the length of that mid-segment is the average length of the bases. So what we're going to do is we're going to have to figure out what those lengths are of those bases, add them together, and divide by 2, because remember, average is taking all of your results and dividing it by how many you have, which is 2 bases. So looking down below, right here, we're going to see what's given, and we're going to see what we're proving. We're actually not going to answer number 2. We're going to skip that, but let's go ahead and read. We kind of did a little fill in the blank with this yesterday, but they gave it to us. So let's just reemphasize this information. It says we have trapezoid EFGH. Now remember, with any quadrilateral, you label it with the 4 vertices, and they have to be the outside ones. It also says if MN is the median, then here's what we're going to know. We're going to know MN is parallel to FG. So MN will be parallel to FG. And we'll also know MN is parallel to EH. So MN parallel to EH. The last piece we talked about is that if we take the lengths of FG and EH, add them together and divide by 2, or in this case, they multiplied by 1/2, we will get the length of MN. So now that we've looked at the trapezoid mid-segment, so make sure, again, you change wherever you see median, like we have up here, and we're going to change it to mid-segments. All right, so now that we have that down, we're going to go ahead and start looking at number 3. So go ahead and head to the next page. So here we have number 3, and what we're going to do is we're going to use the picture of the trapezoid that we had on the previous page for this problem. So go ahead and pause the video right here and go ahead and recreate the trapezoid on the previous page over in the margin on the left side. All right, so I was able to do this right here, and I didn't include what we wrote down before because I want us to practice understanding what the trapezoid mid-segment theorem is. So let's go ahead and read number 3. It says given trapezoid EFGH and MN is a median. We're going to use the figure from item 2, the properties of trapezoids, and or the trapezoid median theorem for each of the following. So we're going to learn about these different properties and explore it. So it tells us if the measure of GFE is 42, we're going to try to find the other angle measures. So let's go ahead and recreate what we did on the previous page, looking at FM and knowing that it's congruent to EM. We're also going to write down that GN is congruent to HN. Now keep in mind, we know that all of the bases, so FG and EH, they're parallel to each other. And we also know that MN is parallel to both of those. So now let's go ahead and label angle GFE. So remember, GFE is going to be this angle up here. So remember, we always follow whatever that middle letter is, where F is. So this angle right here is 42 degrees. Now, it asks for us to find the measure of NME. So we're looking at NME, so we're looking at this angle. So something we're going to see in trapezoids is that this angle measure we just found will actually be congruent to this one. So we can also label that as 42 degrees. So let's go ahead and fill the blank with 42 degrees. That's one of those properties that we're going to learn. Now, let's go ahead and look at the next question. It wants us to find the measure of MEH. So MEH. So we want to find that angle measure. So right now with the information that we have, we don't know how to find that angle measure. But what I'm going to tell you, and this is what we're going to learn, is that these two angles, the one that we focused on and the one that we're looking for, they are going to add to 180 degrees. So that can kind of help us find out what this measure is going to be. We could easily do 180 minus 42. So when we do that, we're actually going to get 138 degrees. So that's what we're going to find the measure of MEH is 138 degrees. Now you're already probably putting things together, and you're going to realize the angle above will also be 138 degrees as well. We're kind of looking at this whole picture as this whole thing is a trapezoid, but it's divided into two smaller trapezoids. So looking at the whole, this angle with the bottom angle are going to add to 180 degrees. That makes sense. 42 up here and 138. So let's go ahead and look at part B next. It says write an equation and solve for x. If FG is 4x plus 4, EH is x plus 5, and MN is 22. So what I want to do is I probably want to label those pieces on this diagram. So let's start with 4x plus 4. So that's the side length of FG. Then we have EH as x plus 5. And then last but not least, we have MN as 22. So remember, thinking about this, we learned for the trapezoid mid-segment theorem that if we add FG plus EH and multiply this by a half, or we could say divide by 2, finding the average of those two bases, we're going to see it's going to equal 22. So what we can do now for part B is now plug in what FG and EH are. So we're going to take 1/2 of FG, which is 4x plus 4. We're going to add that to EH, which is x plus 5. All together, that's going to be times by half, and then it's going to equal 22. So let's start combining some like terms in our parentheses. So we have 1/2 times 5x plus, and we probably want to add 4 and 5, so that way we get 9, and that equals 22. Now, a lot of the time, some of you are probably thinking, yeah, let's distribute that in there. But think about this. If we multiply 1/2 times 5 or 1/2 times 9, we're going to get decimals. I mean, you are more than welcome to do that. That's totally fine. But for me, I'm going to try to think outside the box. And what I'm going to do is I'm actually going to go ahead and think about what's the opposite of timesing by 1/2. It's really saying what is the opposite of dividing by 2. Right? Either way works. So think about this. The opposite of dividing by 2, that's going to be multiplying by 2. So timesing by 1/2 or multiplying by 2 is going to be opposites. Those are going to cancel each other out. So I'm going to multiply by 2 over here. So let's keep working. That means we have 5x plus 9. Remember, because these cancel out right here. Right? Oop, let me try that again. These cancel out right here. But I won't do that so you can see my work. And then on the other side, we got to multiply 22 by 2, which is 44. So now, this is easy peasy, right? We subtract 9. So that way, now what do we have? We have 35. Divide by 5. So that way x equals 7. So really, our equation that we came up with down here, and I can highlight that, was this equation right there. That's what we want to look at. And we also want to look at x equals 7. So instead of writing that up here, I decided to show the work down here. So now, as a little bit of extra practice, I'm going to have you to try to look at letter C. I want you to try that one on your own. It's a little different from what we just did, but it requires you to look at the lengths of FG, MN, and EH. You're not using the same information that you just did before. You're not. So I want you to go ahead, pause the video right here, see if you can try part C. All right, so here's what I was thinking. Since we know the lengths of the trapezoid midsegment and one of the bases, we're trying to find that other base. Now, we're essentially knowing that we can get the length of let's try that again. We can get the length of MN, right, from adding together FG plus EH and dividing by 2. So what we could do here, and since we're not going to do number 4, we can go ahead and cross that out and use a little bit of the workspace below. So looking at this, we can plug in what we know. We know MN as, not 22. That was the last problem. We know it as 19. We don't know FG. We're going to be solving for that, but we do know EH is 12. And we know we're dividing by 2. So let's solve for FG. All right, so this consists of us multiplying both sides by 2. So that's why sometimes I like writing it better as dividing by 2 instead of timesing by 1/2. It's up to your preference, but I think it's easier to solve for one of those missing variables. Okay, so looking at this, multiply 2 times 19. All right, what do we get? We should get 38. So we have 38 equals, and then remember, those cancel out, so we have FG plus 12. Oh, and look this, we can go ahead and subtract 12 from both sides, and we get, well, hey, that was pretty easy. We get 26 for the length of FG. And I know they didn't include units, but I'm going to encourage you to go ahead and write units for that one. So we were able to solve for FG. Now, what's really nice is that we're able to refer back to our quadrilaterals family tree for some of these specific rules. So we're going to go back to that shortly, but I definitely wanted to carry on our lesson, and I wanted to show you and continue on to looking at a more specific type of trapezoid, the isosceles trapezoid. So we can go ahead and start to look at this place below. So, all right, looking at this, hey, we can see an isosceles trapezoid. It's a trapezoid now with congruent legs. So looking at our visual below, we do have a triangle on top, but this is the isosceles trapezoid. That's why with our first example, when we did it up here, right, I wanted to show you where, our legs weren't necessarily congruent. I wanted to show you that way. So now we're going to look at an example where they are congruent. So let's go ahead and we're going to mark AD. Let's go ahead and use the pen. AD. And we're going to mark EC as congruent to each other. So even reading the directions, it says given, triangle ABC. Oh, triangle ABC is isosceles. So guess what? We can mark BD as congruent to BE. And again, we know that these whole lengths are congruent to each other. It says AB is congruent to CB. So AB, this whole length, is congruent to CB. And we know that AD is congruent to CE. So we have all the necessary marked information. Now, it wants us to start filling in some of the blanks. It wants us to look at finding which angle is congruent to angle A. So think back to what we know about isosceles triangles, and we're going to apply it to isosceles trapezoids. So think about maybe a base angle. What's going to be congruent to this base angle? That's right, angle C. So angle C is going to be congruent to angle A. And remember, that's going back to base angles of an isosceles triangle are congruent. We're applying that to trapezoids now. So we're going to write down that base angles in isosceles triangles are congruent. And remember, we're applying this idea to trapezoids. All right, let's keep working downward. Let's look at part B. It says, explain why triangle BDE, so why BDE, why that's isosceles. All right, so technically the information that we have, they didn't necessarily give that BD was congruent to BE, but what they said altogether is that this whole length is congruent to this whole length. So now we kind of have to go through the process and show, okay, how do we know that that top triangle is isosceles? So let's start with what we know. Well, we know that BC, this side length, right, is where we add BE plus CE. So let's go ahead and start writing that down first. So let's write down that BC is equal to BE plus CE. Now remember, we don't include the length measures on top because we have an equal sign. Remember, that's when we don't include having that notation above, when we're having those equal signs and we're talking about lengths, all right? So keep in mind, what do we know about over here? Well, following the same order, we know BA is going to be equal to BD plus AD. And we know that since triangle ABC, right, ABC, since we know it's isosceles, that means that AD and CE are going to equal from knowing that the legs will be congruent with the trapezoid. So we're going to say, since triangle ABC is isosceles, and we know that AD equals CE, right? So since we know AD equals CE, then that means that BD must equal BE. It has to, right? We have to know that, since altogether, it's kind of by that subtraction property. We know these sides are congruent. We know these sides are congruent. So if we took these away from our whole, these are what's left. Therefore, and if you haven't known this already, we can say the word therefore, or if you've seen these little 3 dots that make up a triangle, we can say that. That means therefore. So if you ever see something like this, we have 3 dots that make up a triangle, that means therefore. So here we know, therefore, triangle BDE is isosceles. We were able to prove that. So yesterday we kind of went through a paragraph proof to start looking at different properties of a kite. Now we're doing that with our isosceles trapezoid. So we're doing a good job. Keep it up. So let's go ahead and look at part C right here. So it says AC is parallel to blank. And we have to explain why. So go ahead, look at your picture. AC is parallel to what? That's right, DE. So go ahead and write down DE, put the line segment sign above it, right? Now we have to explain. Well, think about this. We're actually going to go back to different types of angles. Remember, when we have 2 parallel lines, think of how I could extend these lines, right? and we're going to look for maybe different types of angles, right? Think about how one of these sides, now let's pick the left side. Think about how one of these sides is like a transversal. Okay, so let's say AB is a transversal. Okay. Now, looking at this, we know we have angle A. Think of what angle is going to be congruent to angle A that's by our transversal. That's right, we're going to have this angle right up there. Those are corresponding angles. I know, right? So I'm going to make a little note of that. So those angles are corresponding, and we know that corresponding angles are congruent if we have two parallel lines. So we know that angle A, and we're going to call this one not angle D, we're going to use the three letters. So BDE. So we're going to say those are congruent. So angle A and angle BDE, we're going to say are corresponding angles. Therefore, AC is parallel to DE. Let's go ahead and look at part D. We're almost done. This is our last problem. You are right there. So part D says, explain why quad ADEC, so this bottom quadrilateral, explain why it's an isosceles trapezoid. So looking at this, right? Remember, quad ADEC, it has a pair of parallel sides. And it has another pair of sides that are congruent. So that's why it's an isosceles trapezoid. It has one pair of parallel sides and the other pair of sides are congruent. So let's go ahead and write that down. So we're going to say, let's try that again. Quad ADEC, don't forget the fourth letter, has one pair of parallel sides and the other pair of sides is congruent. So that's what we're looking at with an isosceles trapezoid. Those are some of the properties that we're listing. All right, let's look at part E. So part E says angle ADE is congruent to what? All right, and I'm going to just kind of help you on out. Instead of doing the explain piece, let's cross that out. I'm just going to have you fill in which angle it is. So go ahead, fill in which angle that you think it is. Angle ADE is congruent to what? So ADE, let's try again. ADE is this angle right here. We don't know if it's the same as the other ones we found, so I have to go ahead and put different congruence markings. And we're going to see it's going to be congruent to the angle on this side, CED. So this angle right there. So we're going to go ahead and fill in angle CED. Now, we have part F. It's just on the next page, all right? So let's go ahead and start and finish that. All right, I know we don't have our picture. You can refer back to it, but it wants us to fill in the theorem for our specific picture. Now, you don't have to have the picture to do this, but think back on it. So it says the base angles of an isosceles trapezoid. Fill in the blank. What do you think they are? I hope you said congruent because they are. Woohoo! All right, we're done with notes for today. Nice. Now, I'm just going to remind you that we do have our quadrilaterals family tree. So it might be a good idea for you to go ahead and find where that is. Find where your teacher has that. I know I have it on our calendar for today. So go ahead and pull that out, and we're just going to reemphasize what we went over. All right, so what's pretty cool for me is that I was able to pull up our quadrilateral family tree right here. So I know previously with my class we went over our quadrilaterals. We went over the 2 inherited properties by all our quadrilaterals. We saw what kites were. We saw it has 4 different properties and has no pairs of parallel sides. Now, let's go ahead. We're going to look at our trapezoid right here. Yeah, look at that, buddy. Woohoo! So, it's going to have the same 2 properties from up here. It's going to inherit it. We know that we're going to look at, right, 1 pair of parallel sides. So we start that off with our trapezoid. It inherits the 2 properties, and we see the bases are parallel. Now, something else that we notice is, wait a minute, if we continue down below that, that's where we have our isosceles trapezoid. Yeah, look at that. All right. So that one has a couple more rules than just the trapezoid in general. We can see the legs are congruent. The diagonals are going to be congruent. Lower base angles are congruent. Upper base angles are congruent. And any lower base angle is supplementary to any upper base angle. So by now, you should be able to have looked through these and be familiar with them. So what you're going to do right now is you're going to see what homework your teacher has for you. Miss Graham's class, go ahead and check on our calendar, see what the homework is for tonight. All right. Happy mathing with whatever homework adventures you have, and we will see you soon.